Before we go into solving inverses of logs and exponentials, I just want to briefly talk about how logs and exponentials kind of work as opposites in each other, canceling out like addition and subtraction, multiplication, division, squares, and square roots. So for example here, if I have log base 3 of 3 is equal to 1. We know that's true because 3 to the power of 1 is equal to 3. So if I want to go ahead and further use this instead using exponential, I can say that 3 to the power of log base 3 of 8, I know this is going to equal 8. And so to kind of go ahead and work this out a little bit further, if I convert this, let's say I didn't know it was 8, but let's say if I want to go ahead and work this further and set this equal to x, then I can convert this now into log form. So log base 3 of x is going to be equal to log base 3 of 8. What was in my exponent here? And if I have my bases that are the same of 3 and 3, that means x is going to equal 8. So again, that's just another way of showing that x here is equal to 8. In short, if you see something like this, let's say I have, let's say I have 72 to the power of log base 72 of 200. I can just look at the 72 as my base and my log base 72. Know that those two things are going to equal to 1 and just look at my number up here. So I know that this whole entire expression here will equal 200. Another way to think about this as well is, let's say the natural log of e is going to equal 1 because log base e, or ln, is the same thing as log base e. So log base e of e would equal 1. E to the power of 1 is equal to 1. So e to the power of the natural log, again, of any number, let's say 7, that will equal 7. Same way it works, the bases are the same. So just something to keep in mind, thinking about the relationship between the two. And now let's go ahead and move on to solving these inverse questions. So like any inverse question here, I'm first going to want to swap my x and my y. So this will now be x is equal to 5 to the power of y minus 7. I want to isolate this 5 to the power of y, so I will have x plus 7 is equal to 5 to the power of y. And now I'm going to convert this to log form. So I will have 5, or log base 5 of x plus 7. Remember to put your parentheses here because you're taking this whole entire left side right here, is going to be equal to y. And so that is what I would do to find the inverse of this function here. Now we're going to do the same thing, except we're going to do it for logs. So now again, switch my x and my y. So x is going to be equal to 1/2 of log base 3 of y minus 3. I want to get my log by itself first, so that would be 2x, so I'll multiply both sides by 2, is equal to log base 3 of y minus 3. And now I'm going to want to convert this to exponential form. So I will have 3, my base to the power of 2x, my equal, is equal to my argument, which is y minus 3, and I'll just add 3 to both sides. So I will get 3 to the power of 2x plus 3 is equal to y. And so now this here will be my answer. So that is how, one, the relationships between logs and exponentials, how they kind of cancel each other out to equal 1 and just equal our number here in our argument for these examples, or also how inverses of exponentials and inverses of logarithms work.